All right, let's dive right in. Today, we're talking about one of the most ambitious new ideas in physics, a theory that claims it can finally stitch together the two sides of our universe, the massive world of stars and galaxies, and the bizarre, tiny world of quantum particles. It's called the Time Force Hypothesis. So, let me just start with this one massive question. What if everything, and I mean everything you see, everything you are, isn't fundamental? What if it's all just an effect, like ripples on a pond, all born from a single underlying cosmic flow? That's the wild, radical idea we're exploring today. Now, to really get why this is such a huge deal, you have to understand the biggest problem in physics today. We've got these two theories that work incredibly well. General relativity gives us this beautiful picture of a smooth, curving spacetime for all the big stuff. And quantum field theory is amazing at describing the weird, fuzzy, probabilistic world of tiny particles. The problem? They don't talk to each other at all. One can't handle gravity, the other can't handle the quantum world. It's like they describe two totally different realities. So, how in the world do you connect them? Well, the time force hypothesis, we'll call it TFH, says what if you're looking at it all wrong? What if space-time and particles aren't the fundamental building blocks, but are actually just emerging from something deeper? Okay, let's break this down. The absolute core idea of TFH is that energy is the only thing that's really real. The whole universe, it says, is filled with this one single energy field. You can kind of think of it like the air in a room, where every single point has a temperature. In this case, every single point in the universe has an energy value, and everything else, gravity, you, me, the stars, is just a result of this energy field flowing and moving around. It's this beautiful idea that everything is made of just one thing. And get this, TFH boils down all of physics to a single master equation. You can think of it like a recipe for creating a universe. It's got four key ingredients. First, inertia. The energy field doesn't like to change. Second, propagation. That's how the energy moves around, like a wave. Third, dissipation. This is a kind of cosmic friction that's super important because it gives time its forward direction. And last, self-interaction, which is what allows the energy to bunch up and form stable things, like us. Okay, so what does this recipe actually cook up? Well, the first major thing it completely changes is our understanding of the one force we all feel every second of every day: gravity. And here's where your brain might start to hurt a little in a good way. TFH says gravity is not a force. It's not some invisible string pulling you down. It's not even the bending of space-time that Einstein so brilliantly described. So, if it's not a force and it's not bent space-time, what on earth is it? Well, what if it's just a flow? This leads to the river of energy model, which is just an incredible way to picture it. Imagine the entire universe is this giant river of energy. Now, massive things like the sun or the earth, they're like drains in the riverbed. They cause the energy to constantly flow towards them. So that feeling of being pulled by gravity, that's just you being carried along by the current. And a black hole? That's a spot where the river is flowing at the fastest speed possible, the speed of light. And you know what's so cool about this? This one idea just solves one of the oldest mysteries in physics, the equivalence principle. Why do a feather and a bowling ball fall at the same speed? In the river model, the answer is just obvious. They're both made of the same energy water, and they're both just floating in the same current. Of course they fall together. It just naturally pops out of the theory. Okay, so a whole new way to think about gravity? That's huge. But the theory is even more ambitious. It claims this one single flow can create not just the huge cosmos, but the tiny quantum world too. So how does it do that? Well, it redefines what a particle even is. In this picture, particles aren't little billiard balls. They're more like stable, self-sustaining waves. Think of them as persistent little wrinkles in that cosmic river of energy. And this is where you really see the unifying power of it all. Standard physics needs totally separate explanations for these huge concepts. But in TFH, it's all one connected story. Gravity, that's just the energy flowing. Particles, they're just stable waves in that same flow. Even the expansion of the universe gets a new explanation. It's not space-time itself stretching, it's the entire river of energy just calming down over billions of years, causing all the waves within it to get longer. Okay, this all sounds like a beautiful, elegant story, right? But here's the most important question. Is it just a cool idea, or is it actual science? Can we test it?
And the answer is a huge yes. The theory makes real, testable predictions that could prove it wrong, which is the hallmark of good science. For one, it says that when black holes merge, we should see faint echoes in the gravitational waves, as if they're bouncing off a surface. Two, it makes a very specific prediction about when the most stars were being born in the universe's history. And three, and this is wild, we can actually test its equations in a lab by creating things that act like black hole horizons using super cold atoms.
Let's just zoom in on that second prediction for a second, because it's a big one. THS doesn't just make a vague claim. It calculates a very specific history for star formation. It says that star making hit its absolute peak at one particular moment in time and then started to decline. And that's something our best telescopes, like the James Webb, can actually go out and look for. It even gives us a number to hunt for, a redshift of about 3.5. That's the exact point in cosmic history when TFH says the universe was at its most creative. And what's really amazing is that this specific number actually lines up pretty darn well with the data we already have. It's a real, tangible prediction we can go out and verify.
There's a quote from the original paper that just poetically sums up this whole grand vision. It says, "The universe is a wave. Its boundaries whisper entropy, its flows carve spacetime, and its echoes reveal the future."
And that really leaves us with this one final, profound thought. Is it possible that our entire reality, from the smallest atom to the biggest supercluster of galaxies, is really just one thing? A single, vast, universal flow creating all the complexity and beauty we see around us? The Time Force hypothesis has the audacity to say yes.